Hello my good friends, Derek Deschamps here for Internetworking Influencers, your source for free Cisco certification training for network engineers. Welcome to day 7 of our free CCNA 100-105 ICND1 training course. The Internetworking Influencers CCNA 100-105 ICND1 training course is comprised of 13 videos, each focusing directly on a set of specific items on Cisco's official exam topic list. Today's episode will cover item 2.4, configure, verify, and troubleshoot VLANs in the normal range spanning multiple switches, including access ports for data and voice, and the default VLAN. Item 2.5, configure, verify, and troubleshoot inter-switch connectivity, including trunk ports, 802.1q, and the native VLAN. Item 2.6, configure and verify Layer 2 protocols, including Cisco Discovery Protocol and LLDP. And lastly, item 2.7, configure, verify, and troubleshoot port security, including static, dynamic, sticky, max MAC addresses, violation actions, and err-disable recovery. As a reminder, today's video has a set of free practice questions that are available on our website at internetworkinginfluencers.com that will help you brush up on the topics you learned today. The questions are a true representation of the types of questions you'll face on the actual exam, so be sure to check those out once we're done. Today we are going to start things off by taking a detailed look at VLANs. A virtual LAN or VLAN is used to divide switches into separate logical segments, or broadcast domains, providing layer 2 separation. Devices that are on the same VLAN can communicate directly without using a router. However, devices that are on different VLANs must communicate through a router. A single VLAN is typically used for all devices on a single subnet. For example, if two devices are connected to a switch and on the same VLAN, they can communicate directly without the need of a router. Since each VLAN represents a single broadcast domain, they can also receive each other's broadcast frames. However, if two devices are connected to a switch and on different VLANs, they are separated at layer 2, in separate broadcast domains. This means they cannot communicate directly and will not receive each other's broadcast frames. In order for the devices to communicate, a router must be used to route traffic between the two VLANs at layer 3. This allows the devices to communicate directly with each other. However, since routers do not forward broadcast frames, the devices will still be in separate broadcast domains and will not receive each other's broadcasts. Alright, so now that we know how VLANs function, let's take a look at how to configure them. I'll begin by logging into a switch that is configured with the default settings and going into privileged exec mode by entering the command enable. Now to view the VLAN information on the switch, we can enter the command show VLAN. Here we can see that by default, all switch ports are in VLAN 1. VLAN 1 is the default VLAN for all ports and cannot be deleted. VLANs 1002 to 1005 are also created by default and are used for FDDI and token ring. The normal range of VLANs range from 1 to 1005. If we wanted to create a new VLAN, we could use any number in that range that is not already used. There is also an extended range of VLANs from 1006 to 4094. However, those are beyond the scope of this exam. So to configure a new VLAN, we must first enter Global Configuration Mode by typing Configure Terminal. To create a new VLAN, we now type VLAN, followed by the VLAN number we want to use. In this case, 2. You will notice that the command prompt changed to config-VLAN in parentheses. This indicates we are now in VLAN configuration mode. If we wanted to name our new VLAN, we could do that here by typing name followed by the name we want to use. In this case, finance. Let's create another new VLAN using the same procedure. To do this, we type VLAN followed by the VLAN number we want to use. In this case, 3. This time, let's name our new VLAN Voice by typing name Voice. To exit VLAN configuration mode, we type exit, which takes us back to global configuration mode. To exit global configuration mode, we type exit again. So let's verify that our new VLANs have been created. To do this, we type show VLAN. Here we can see our new VLAN 2 with the name Finance, and our new VLAN 3 with the name Voice. We can also see that no ports are assigned to these new VLANs. So let's do that. To assign ports to a VLAN, we once again go into Global Configuration Mode by entering the command Configure Terminal. We now enter Interface Configuration Mode for the interface we want to change by entering the command Interface followed by the interface type and number. In this case, Ethernet 0/0. Before we assign any VLANs to this port, we're going to ensure it is configured as a static access port, as opposed to a trunk. We do this by entering the command switch port mode access. So now to configure this port to use VLAN 2 for data, we enter the command switch port access VLAN 2. If a phone was plugged into this port and we wanted to use VLAN 3 for voice, we could enter the command switch port voice VLAN 3. To exit interface configuration mode, we type exit, which takes us back to global configuration mode. To exit global configuration mode, we type exit again. To verify that Ethernet 0/0 is now in the correct VLANs, we type the command show VLAN. Here we can see that Ethernet 0/0 is in both the finance and voice VLAN. For more detailed information about the switch port, we can enter the command show interfaces Ethernet 0/0 switch port. Here we can see that the administrative mode is set to be a static access port. We can also see that the access mode VLAN is VLAN 2. And the voice VLAN is VLAN 3. Now that we have a thorough understanding of VLANs, let's take a look at how VLAN traffic is carried across a network by using trunking. A trunk port is used to carry traffic from multiple VLANs between devices, while maintaining layer 2 separation. For example, if we have VLANs 1, 2, and 3 on one switch, and VLANs 1, 2, and 3 on a second switch, we can connect the two switches with a trunk. This allows traffic from all three VLANs to be carried across a single link. Now hosts in a single VLAN on one switch can communicate with hosts in the same VLAN on the second switch. 802.1q encapsulation is used to identify which VLAN an Ethernet frame belongs to as it traverses a trunk link. The VLAN is identified by inserting the VLAN number, also referred to as a tag, into the Ethernet frame header. All Ethernet frames that traverse an 802.1q trunk link are tagged with the VLAN number, except for frames on the native VLAN. If a frame is received on an 802.1q trunk and it does not contain a VLAN tag, it is assumed to be on the native VLAN. The native VLAN can be specified manually, otherwise VLAN 1 is used by default. Now that we know how a trunk port is used, let's take a look at how to configure one. I'll begin by logging into a switch that is configured with the default settings and going into privileged exec mode by entering the command enable. Now to configure a trunk, we need to enter global configuration mode by typing configure terminal. We now enter interface configuration mode for the interface that we want to configure as a trunk by typing interface followed by the interface type and number, in this case Ethernet 0/0. We begin configuring the trunk by setting the trunk encapsulation to 802.1q by typing switch port trunk encapsulation .1q. We can then set the native VLAN by entering the command switch port trunk native VLAN followed by the VLAN number, in this case 2. Now by default, all VLANs would be allowed on our trunk. If we only wanted to allow VLANs 2 and 3 on our trunk, we could specify that here by typing switch port trunk allowed VLAN 2, 3. So now that we've specified all the parameters for our trunk, we can enable the trunk by typing switch port mode trunk. We can then exit out of interface configuration mode by typing exit. and exit out of global configuration mode by typing exit again. So let's verify the configuration of our new trunk. To do this, we enter the command show interfaces trunk. Here we can see Ethernet 0/0's trunking mode is on. Encapsulation is 802.1Q. The current status is trunking, and the native VLAN is VLAN 2. We can also see that only VLANs 2 and 3 are allowed on the trunk. The next topic we are going to look at today is how Cisco devices use device discovery protocols to learn about their connected neighbors. The Cisco Discovery Protocol, or CDP, is a Cisco proprietary protocol that is used by a Cisco device to discover information about its directly connected neighbors. The information is discovered by listening for periodic CDP advertisements that are sent by CDP-enabled devices. Received CDP advertisements are never forwarded. The information that is discovered can be used by network management applications or viewed directly by a network engineer. Alright, so let's take a look at how to view the information that is discovered by CDP. I'll begin by logging into a switch that is configured with the default settings, and going into privileged exec mode by entering the command enable. CDP is typically enabled by default on a Cisco device. To ensure CDP is enabled, we can use the command show CDP. Here we can see that CDP version 2 advertisements are enabled, and the device is sending CDP packets every 60 seconds. We can also see that the hold time is set for 180 seconds, which means the device will retain the information it receives for 180 seconds before discarding it. CDP is also typically enabled on each interface by default. To view the interfaces that CDP is enabled on, we can use the command show CDP interface. Here we can see that CDP is enabled by default on all our interfaces. To view information that CDP has discovered from other CDP-enabled devices, we can use the command show CDP neighbors. Here we can see that a device with a hostname border-router-1 is connected to the local interface Ethernet 0/0. We can also see that the device is a router by the capability code of R. The device is a 7206 VXR, and the port ID at the remote end is fast Ethernet 0/0. To view more detailed information about each CDP neighbor, we can issue the command show CDP neighbors detail. Here we can see the IP addresses of the remote device, the iOS version, and the duplex of the port. So as I mentioned, CDP is typically enabled by default on a Cisco device. If we wanted to disable CDP globally on a device, we would enter Global Configuration Mode using the command configure terminal and issue the command no CDP run. To re-enable CDP globally, we use the command CDP run. If we wanted to disable CDP on a specific interface, we would enter interface configuration mode for that interface by entering the command interface followed by the interface type and number, in this case Ethernet 0/0. We would then use the command no CDP enable. To re-enable CDP on the interface, we would use the command CDP enable. The Link Layer Discovery Protocol, or LLDP, provides the same functions as CDP, only it works with non-Cisco devices. To show you how LLDP works, I'll begin by logging into a switch that is configured with the default settings and going into privileged exec mode by entering the command enable. Unlike CDP, LLDP is not typically enabled by default. To determine if LLDP is enabled, we can use the command show LLDP. Here we can see that LLDP is not enabled. To enable LLDP globally, we would enter Global Configuration Mode by typing configure terminal and then issue the command LLDP run. Once LLDP is enabled globally, it will also be enabled by default on each interface. If we wanted to disable LLDP on a specific interface, we would enter interface configuration mode for that interface by entering the command interface followed by the interface type and number, in this case Ethernet 0/1. To prevent the interface from sending LLDP advertisements, we use the command no LLDP transmit. To prevent the interface from receiving LLDP advertisements, we would use the command no LLDP receive. Now, if we exit out of interface configuration mode by typing exit, and exit out of global configuration mode by typing exit again, we can verify our changes by typing show LLDP, which shows us that LLDP is now active. If we use the command show LLDP interface, we can see that LLDP is enabled on all interfaces, except for Ethernet 0/1, where we disabled it for both transmitting and receiving. To view the information that LLDP has discovered from other LLDP-enabled devices, we can use the command show LLDP neighbors. Here we can see that border-router-2 is attached to interface Ethernet 0/2. We can also see that the remote device has a capability code of R, meaning it's a router. We can also see that the port ID at the remote end of the connection is Ethernet 0/1. To view more detailed information about each LLDP neighbor, we can use the command show LLDP neighbors detail. Here we can see more detailed information about the remote device, including management IP addresses and a system description. As I'm sure you've noticed, most of the commands and show command outputs are nearly identical to CDP. The main difference between the two protocols is that CDP will only work with Cisco devices, where LLDP will work with non-Cisco devices. The last topic we will look at today is port security. Port security is used to control how many devices are allowed to send Ethernet frames into an interface. Control is based on the source MAC address of the incoming frame. Access can be restricted to specific MAC addresses. Port security is typically used to prevent users from plugging unauthorized devices into access ports. A port security violation occurs when the maximum number of MAC addresses allowed to connect to a secure port is exceeded. There are 3 violation modes that can be used to determine what happens when a violation occurs on a secure port. Protect mode will drop the frame. Restrict mode will drop the frame, increment the violation counter, and generate a notification to the console and SNMP. Shutdown mode is the default mode and will shut down the port by placing it in err-disabled state and perform the same actions as restrict. Now that we know how port security functions, let's take a look at how to configure it. I'll begin by logging into a switch that is configured with the default settings, and going into privileged exec mode by entering the command enable. To enable port security on an interface, we begin by entering global configuration mode by typing configure terminal. We then enter interface configuration mode by typing interface followed by the interface type and number, in this case Ethernet 2/0. In order to configure port security on a port, it must first be configured as either a static access port or a static trunk. In this case, we'll configure the port as a static access port by entering the command switch port mode access. Now, if we want to set the maximum number of MAC addresses that are allowed to send frames into the port, we can use the command switch port security maximum followed by the maximum number of MAC addresses. The default for this command is 1. Let's change it to 2. If we want to change the violation mode, we can use the command switch port security violation followed by either protect, restrict, or shut down. In this case, we'll just stick to the default of shut down. We can now enable port security on the port by typing switch port, port security. Port security will now dynamically learn the source MAC addresses on the port. This is all the configuration we need if we only want to control how many devices are allowed to send Ethernet frames into the port. If we want to statically configure which MAC addresses are allowed to send frames into the port, we can use the command switch port, port security, MAC address, followed by the MAC address. In this case, AAAA.BBBB.CCCC. If we want to restrict access to the devices that are currently connected to the port, but do not know their MAC addresses, we can use the command switch port, port security, MAC address, sticky. The switch will then take any dynamically learned MAC addresses and create static entries in the running configuration for us. Now, if we exit out of interface configuration mode by typing exit, and exit out of global configuration mode by typing exit again, and if we look at the running configuration for this interface by typing show, running config, interface, Ethernet 2/0, we can see the static MAC address entry that we manually configured, as well as a second sticky MAC address entry that the switch added for us. We can view the port security information for all secure ports by typing show, port security. Here we can see that Ethernet 2/0 has been configured as a secure port. We can see that the maximum number of MAC addresses allowed on the port is 2, and that the current address count is also 2. We can also see that no violations have occurred, and that the violation mode has been set to shut down. To view more detailed information about port security on a particular interface, we can use the command show, port security, interface, followed by the interface type and number, in this case Ethernet 2/0. Here we can see more detailed information, including the port status, which is currently showing secure up. We can also see the last source MAC address that was seen by the switch. So now I'm going to add a third device to the port, so we can see what happens. As you can see, port security just logged a notification to the console, stating that a violation has occurred, and that the port has been shut down by placing it into err-disabled state. If we issue the command show, port security, interface, Ethernet 2/0, we can see that the port status has changed to secure shutdown, and that the violation count has been incremented to 1. If we issue the command show interfaces Ethernet 2/0, we can see that the port is in err-disabled state. So once the problem has been corrected, and we are ready to re-enable a port that has been placed into err-disabled state, we go into global configuration mode by typing configure terminal. We then enter interface configuration mode by typing interface, followed by the interface type and number. In this case, Ethernet 2/0. Now, we simply shut down the interface by entering the command shutdown, and re-enable the interface by entering the command no shutdown. Now, if we exit out of interface configuration mode by typing exit, and exit out of global configuration mode by typing exit again, and enter the command show port security interface Ethernet 2/0, we can see that the interface now has a status of secure up. And if we enter the command show interfaces Ethernet 2/0, we can see that the port is no longer in err-disabled state. And that brings us to the end of Day 7 of Internetworking Influencers CCNA 100-105 ICND1 training course. Don't forget to complete the free practice questions for today's material, which can be found on our website at internetworkinginfluencers.com. The free questions will help highlight the key points that Cisco will expect you to know for the exam. Also, if you enjoy our free training and would like to show your support, please check out our Patreon page. We offer numerous perks to our supporters, ranging from additional practice questions and detailed study notes for each video, to direct access to our instructors to answer any questions you might have. I'll be back next time for Day 8, where I'll cover routing concepts and routing table components. I'm Derek Deschamps for Internetworking Influencers. Thanks for watching.